Building multi-container applications. Modern applications rarely consist of a single container. Applications often include front-end, back-end, databases, and caches. Docker Compose manages all services from a single file. This lesson explores building complete multi-container applications. Understanding application components. A typical application stack. Front-end. Back-end API. Database. Each component performs a specific role. Front-end service. Responsibilities. User interface. User interaction. Displaying data. Sending requests. Examples. React. Angular. Vue. Backend service. Responsibilities. Processing requests. Authentication. Validation. Database operations. The backend connects the frontend and database. Database service. Responsibilities. Store data. Retrieve data. Maintain persistence. Examples. MySQL. PostgreSQL. MongoDB. Traditional deployment challenges. Without Compose. Create network. Start database. Start backend. Configure variables. Start frontend. Connect services. This process is repetitive and error-prone. Docker Compose solution. Compose allows us to define services, networks, volumes, environment variables. Everything is managed from one file. Building our application stack. We will create front-end service, back-end service, MySQL service. All services run together as one application. Basic Compose structure. Version 3. Services. Front-end. Back-end. Database. Each service receives its own configuration. Defining the database service. Example. Database. Image, MySQL 8. Compose automatically downloads and starts the database image. Configuring database variables. Example. MySQL_root_password equals password. MySQL_database equals apt. Environment variables customize database behavior. Adding persistent storage. Example. MySQL data /var/lib/MySQL. Benefits. Data persistence. Container independence. Reliable storage. Defining the backend service. Example. Backend. Image, MyBackend. The backend processes requests and communicates with the database. Backend environment variables. Example. DB_host equals database. DB_port equals 3306. Service names replace hard-coded IP addresses. Why service names matter. Benefits. Automatic DNS resolution. Easier configuration. More reliable communication. Docker Compose handles service discovery automatically. Defining the front-end service. Example. Front-end. Image, MyFrontend. The front-end provides the user interface. Publishing front-end ports. Example. Ports. 3000:3000. Users access the application through the published port. Complete communication flow. Application components. User. Front-end. Back-end. Database. Docker networking connects all services. Automatic network creation. When running. Docker Compose up. Docker automatically. Creates networks. Connects containers. Configures DNS. Compose network architecture. All services share. One Compose network. Internal DNS. Secure communication. Manual network creation is unnecessary. Starting the application. Command. Docker compose up. Compose. Creates containers. Creates networks. Creates volumes. Starts services. Running in detached mode. Command. Docker compose up D. Benefits. Background execution. Terminal remains available. Ideal for development. Viewing running services. Command. Docker compose PS. Displays. Container status. Service names. Port mappings. Viewing application logs. Command. Docker compose logs. Benefits. Centralized logging. Easier troubleshooting. Service visibility. Viewing logs for one service. Example. Docker compose logs backend. Useful for debugging specific services. Restarting services. Command. Docker compose restart. Compose can restart entire application. Individual services. Stopping applications. Command. Docker compose down. Removes. Containers. Networks. Volumes remain unless explicitly deleted. Why volumes are important. Without volumes. Container deleted. Database deleted. Data lost. Volumes preserve application data. Real-world application example. E-commerce platform. Frontend. Backend API. MySQL database. Docker compose manages the entire stack. Adding Redis to the stack. Benefits. Faster performance. Reduced database load. Improved scalability. Compose makes adding services easy. Benefits of multi-container applications. Service separation. Easier maintenance. Better scalability. Independent updates. Improved reliability. Common beginner mistakes. Missing environment variables. Incorrect port mapping. Ignoring volumes. Hard-coded IP addresses. Compose helps reduce these problems. Best practices. Use descriptive service names. Store data in volumes. Avoid hard-coded values. Separate application layers. Keep files organized. Compose workflow recap. Workflow. Create compose file. Docker compose up. Application running. Docker compose logs. Monitor services. Docker compose down. Key takeaways. Compose simplifies multi-container applications. Services communicate using Docker networking. Compose provides automatic DNS. Volumes provide persistence. Entire stacks start with one command. Interview question. Question. Why do Docker compose services use service names instead of IP addresses? Answer. Docker compose provides automatic DNS-based service discovery, allowing containers to communicate reliably without depending on changing IP addresses. Lesson summary. Multi-container applications contain multiple services. Compose manages networking and communication. Service discovery simplifies connectivity. Volumes protect persistent data. Compose streamlines deployment and operations. Modern applications commonly use this architecture.